doing with that flashlight?
My project is too gimmicky, I think. I have to have a solar panel and FPCC water.
It's a GoPi Go Raspberry Pi robot powered by Amazon Alexa, and when you give Amazon Alexa command through my smartphone, it'll move the robot. Okay. So here we're gonna explain a little bit how Alexa bot works. So I'm remote accessed into my Raspberry Pi, and here we're running the app and a server that runs the commands and the code to the Alexa bot, and then it runs it back through a domain forwarder, and it runs our code. And so it runs it through if this then that, which takes a command and then performs a function. So in this instance, we're gonna say Alexa trigger left, and then it makes a web request to Amazon Alexa. So here we have an Alexa app on my smartphone. So I'll hold it down and I'll say, Alexa trigger left.
Sorry, I don't see that IFT trigger.
Alexa trigger left. And then it usually takes a couple tries.
Sending that to IFT.
But once it gets through, the Alexa bot will work. And you can see our commands are coming in one at a time. And so you can see the port forwarding in action. Alexa trigger forward.
Sending that to IFT.
So we see our command come in, and we see the Alexa bot move forward, and then we can say Alexa trigger backward, and then it gets the command, and then it manages to transfer it through if this then that, and then we see Alexa trigger backward. We can see Alexa in action.
Sorry, I don't see that IFT trigger.
Alexa trigger backward.
Sending that to IFT.
So sometimes it takes a couple tries, but as long as we know it works, it's very cool to see Alexa in action. Alexa trigger dance.
Sending that to IFT.
So that's just a little demonstration of how Alexa works behind the scenes. It's a lot of code and fancy port forwarding and if this then that statements and our smartphone app. But in the end, we get a dancing Alexa, and I guess that's what's best.
This is a pet rover that chases a ball around. The robot has a sensor, an ultrasonic sensor that detects how far or how near the ball is. If it gets near, it will trigger the servo to close and to grab the ball. There's also the motor driver underneath to control the wheels that is similar to a tank. There are batteries underneath, and there's a Bluetooth module underneath also. The Bluetooth is paired with the another Bluetooth module inside the case here, and the Bluetooth module is attached to the voice recognition. The voice recognition is where we can say commands to tell what we want it to do. So if I turn this on, it will wait 5 seconds. That is to give time for the Bluetooth to pair, and then the Bluetooth will send data and receive data from the Arduino. So if I say a command, for example, doggo, it has to be said multiple times. So doggo, doggo, doggo. It'll go. It'll listen to commands, and if I say stop, 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 it will stop. There's also the ball here, or I can have it near the clock. It will try to grab it. There, grabs the ball. It won't let go till it's gone, so I have to lock its view. Then it can look around, look around, look around, it will look around, but it won't try to find the ball. Stop. Stop. And it can also try to find the ball. Fetch. Fetch. So start looking for a ball. So it's different for lighting. And it does see the ball. But it doesn't have good tracking for it right now. Stop. Stop. For now, accelerate. Stop. That is all for now. It's work in progress, but it's a lot of work.
For my project, I decided to make an obstacle avoidance robot. What that does is when my robot encounters an obstacle to the side or to the front of it, it will reroute and move until it finds another obstacle to avoid. It does that with this sensor, which sends out sonar and receives it back to see things around it. And it's placed on a servo, which turns it 180 degrees so it can see left, right, and forward. And that's mounted on a chassis with 4 wheels. Each of them have their own motor. And all of the code is kept here in the Arduino board and the motor shield. And there's a switch on the back to turn it on and off.
My project is a smoke alarm notifier, and what it's going to do essentially is use this microphone and the board inside the enclosure, and it's going to listen for the beep of the smoke alarm, and when it catches it, it's going to text the number, call it, and then email you. It's essentially going to be set up on the wall next to one on the ceiling or something, and so it's got to be relatively close. So I'm just going to put it right here and demonstrate. I hope it works. Oh, okay. As you can see, I got it in the app that it ran, and in a second I got a phone call. Take a listen.
A smoke alarm was sent from Smoky Alarm on a call at location 119 East at Kitchen, which may mean something isn't right at your home. Message brought to you by it.
Yeah, okay, so it'll give you a phone call, notify you in the app if you downloaded it, and it'll even send you a text message saying it went off. So here it is inside the enclosure. We've got the development board plugged in, and I cut a little hole in the back so that I can run through. This is the board that is programmed. It's got onboard Wi-Fi. If I could flip it around to here. That's the Wi-Fi module, so it connects to the internet, and it's able to use a free service to call you and text you and email you. This is the microphone it's plugged into. 2 of them are power, 1 of them just runs the coding. And this one light means it's on, and in fact I can show it now. The second light will blink for a brief second when it detects it. And that's how you know that it worked. The potentiometer here can be edited to make it more sensitive to noise or less sensitive to noise. And that's what I use to get the right noise level. And it called me again. It needs Wi-Fi, and that's about it.
My project for robotics was to make a simple bar top 2-player arcade system. I had to make the console using the Raspberry Pi, and the coding was pretty simple because I had to flash an image onto the SD card right here. Using this is where the magic happens. If they would let me show it. This is the brain of it all. There's buttons right here in their numerical order, so I had to go with A, B, X, Y, and then whatever these were the triggers. They could be anything. I set them as my triggers. This is the Retro Pi in action. I have it set up in the basic way with the joystick controller, so I could go up and down, and then pause it. This is my second project I made with an Arduino Uno. I had to use a piezo buzzer, 3 LEDs, 4 resistors, and a bunch of wires to connect it to this radar right here. It sends out a signal, sort of like how you would think of some echolocation. It's a proximity sensor, essentially. The closer something to it gets, the more it's going to start blinking, warning you how close something is. If you get too close to it, it starts making this little buzzing sound right here.
Okay.
My project is a robotic snake named Slytherin. It is composed of 8 servos that are connected to an Arduino Mega Shield. Due to the coding, it makes the servos go in unison, like the shape of a snake.